In this question, we need to verify that f and g are inverse of each other, algebraically as well as graphically. Algebraically, we have to prove that f of gx should be equal to g of fx should be equal to 1. So let's find f of gx. F of gx is nothing but inside x cube. We need to replace that by gx. So we have to find gx cube, and gx is nothing but cube root of x. So cube of cube root of x is just x. And likewise, g of fx is nothing but we replace this x by fx. So we have x cube, cube root of fx, cube root of x cube, which is just x. So these are the two values of x, and so we have proved that, I'm sorry, I haven't written 1 over here. These two should be equal to x, and that's what we have proved. And graphically, if these are the graphs of all the of both the functions, this is cube root of x, this is x cube, and this is the line y equal to x. So in order for the two functions to be inverse of each other graphically, they should be symmetric about y equal to x. And clearly we can see that this particular function is like this, and this is symmetric about this particular of this particular function about y equal to x. So this is a proof graphically.